Assalamualaikum.
Waalaikumsalam.
Testing.
Yep, clear, Dr. Hazlin.
Thank you, Dr. Mandy.
Dr. Farah, can you try? Test 1, 2, 3.
Hello, can you hear me?
Yep.
All right.
I can hear any voice. Is it my
No.
notebook is muting or?
We can hear you loud and clear, Prof.
Okay. Thank you. So we are going to start at 2:30 or 3 o'clock.
2:45, Prof.
2:45. Okay, we have another time. Let's see. 2:45. Now 2.
Hi everyone.
Hi, Dr. Nadim.
Hi. So we have Prof. Sulaiman here.
Yes, Nadim, I'm here.
Okay. Okay, so we look like we have a very good attendance this afternoon. Eh?
Yeah, we have 58 already in the room.
Oh, yeah.
Good afternoon, Miss Go. Have you tested your audio? Dr. Nadim, can you hear Miss Go? Voice the sound clearly?
I cannot hear her voice.
Yeah, me
Miss
too.
Go, are you there?
Okay, we have to
trying to test
yeah.
your mic. Is it okay? Miss Go?
So we have to.
Can you hear me?
Okay.
Yeah.
Good
Okay,
afternoon.
okay.
All right,
Yes,
sorry.
loud and clear.
Okay, thank you.
Assalamualaikum everyone.
Waalaikumsalam.
Wana from Pekat here.
Hi, Wana.
Hi, if I can have a minute to extend my heartfelt congratulations to Dr. Hazlin on her associate professor.
Waalaikumsalam.
Congratulations.
Waalaikumsalam, Wana. Thank you very much.
Congrats. Boleh panggil Prof lepas ni?
Tak boleh lagi. Dia tunggu sama
Full
tangan dengan
prof,
Prof
full
Sulaiman.
prof.
Full Prof.
Coming soon, come.
Amin, amin. Long way to go.
Alright.
Thank you, Wana, for coming.
Thanks for inviting, Doctor.
Sure. One of the industry player.
Ladies and gentlemen, we have about 5 minutes before we begin our program. So as we are about to begin, I have a few housekeeping notes to make before we start. First, I would like to seek your cooperation to kindly mute your microphone to avoid echoing during this webinar. Second, you can type all the questions in the chat box of the Google Meet or YouTube Live, and these questions will be read out by our committee. Thank you for your cooperation and attention.
Dr. Farah? Dr. Farah, are we about to start?
Yeah, I forgot that I haven't unmuted. Okay. Good afternoon, ladies and gentlemen. Welcome to the first webinar in 2021 organized by SPECTRA and GERC. I'm Farah here, and it is my delight to be your MC today. To kick off this program, we are pleased to have with us the head of SPECTRA, Associate Professor Dr. Hazlin Zainuddin, to deliver the welcoming speech. Please, Doctor.
Thank you, Ms. Farah. Assalamualaikum and a very good afternoon. Yang berbahagia, Prof. Dr. Abdul Malik Marwan Ali, Deputy Dean Research, Industrial Linkages and Alumni, Faculty of Applied Sciences, University Technology, Mara, Malaysia. Yang berusaha, Associate Prof. IRTS Dr. Shahril Irwan Sulaiman, Head of Green Energy Research Center, GERC. Faculty of Electrical Engineering, UiTM, the co-organizer of this webinar. Yang dihormati, our respected keynote speaker, Ms. Koh Hyuk Man, Regional Sales Manager, Canadian Solar, Southeast Asia Private Limited, Singapore. Colleagues, guests, all students, ladies and gentlemen. Good afternoon and a very warm welcome to this webinar entitled New Generation Photovoltaic Modules. On behalf of the organizing committee and all participants, I would like to thank Prof. Malik Marwan Ali, who is representing the Dean of Faculty of Applied Sciences, University Technology Mara, for your presence to grace and launch this event. I would also like to express deep gratitude to the advisor of this event, Prof. Sulaiman Shahri, for his initiative and guidance. It is indeed a privilege for us to have our keynote speaker today, Ms. Koh Hyuk Man. On behalf of the host, the organizer, and all participants, I would like to express our deepest gratitude to Ms. Koh for accepting our invitation to share your expertise in the latest development of PV module technology. Today, we have participants from universities and industries joining this webinar. Everyone's presence here is very much appreciated. Ladies and gentlemen, UiTM's involvement in solar PV technology is not merely on paper. In fact, UiTM is the first Malaysian public university to own 2 large-scale commercially operated solar PV generation plants. Presently, UiTM Holdings has 2 large-scale solar farms, 50 megawatt AC in Gambang, Pahang, and 25 megawatt AC in Pasir Gudang, Johor. In addition, the Solar Photovoltaic Energy Conversion Technology Research Application, SPECTRA, and the Green Energy Research Center, GERC, are 2 active groups that are involved in PV research and development efforts in UiTM. In fact, SPECTRA and GERC have been working together all these years, and this webinar is our first activity in 2021. We both look forward to many more years of synergized work in PV together with industry players. I truly believe this webinar will shed some light into the fast developing PV technology, especially by getting direct updates from the industry players. Lastly, on behalf of the organizers, I would like to express my deepest appreciation to all for spending your time on this platform and make this webinar a success. To all committee members, thank you very much. Have a fruitful session. With that, I pass to Madam MC.
Thank you, Dr. Hazlin, for the welcoming speech. Next, we are pleased to invite Professor Dr. Abdul Malik Marwan Ali, the Deputy Dean of Research, Industrial Linkages and Alumni, Faculty of Applied Sciences, to deliver his speech and launching the webinar. Please, Prof.
Assalamualaikum. Thank you, Dr. Farah. Everybody hear my voice? Okay. So, Assalamualaikum and very good afternoon to all the participants in this event today. Yang berusaha, Associate Prof. Dr. Hazlin Zainuddin, Chairman of webinar and also Head of Solar Photovoltaic Energy Conversion Technology, Research Application SPECTRA Group, yang berusaha Associate Prof. Engineer Technologist Dr. Shahril Irwan Sulaiman, Head of Green Energy Research Center Groups, FKE, UiTM, yang dihormati our respected keynote speaker, Ms. Goh Yuk Mam, Regional Sales Manager, Canadian Solar Southeast Asia Private Limited Singapore, colleagues, guests, all students, and ladies and gentlemen. On behalf of the Dean of Faculty of Applied Science, UiTM Shah, Prof. Dr. Hajah Faridah Zuraina Muhammad Yusof, I would like to congratulate the main organizer and host of this event, that is SPECTRA, and the co-organizer, Green Energy Research Group, Green Energy Research Center Group, GERS, from the Faculty of Electrical Engineering. It gives me great pleasure to welcome all of you to this event to officiate the launching of this webinar entitled New Generation Photovoltaic Module. Solar photovoltaic technology enjoy the fastest growth in terms of applications, not just in Malaysia, but also throughout this region and the world. In fact, it is noteworthy to mention that UiTM, through its business arm, UiTM Holding, has 2 large-scale solar farms, as mentioned by Pengurusi just now, with the capacity at Gamban around 50 megawatt AC, and then another solar farm at Pasir Gudang, located at Pasir Gudang, with capacity around 30 megawatt AC. A solar farm is designed to produce enough electricity for thousands of homes and business. So to harvest the solar energy, basically we need a PV module to convert the sun energy into electricity. And today, we are very fortunate to have Ms. Goh Yuk Mam with us as a keynote speaker to share the new developments on PV module. The faculty appreciate you taking time off from your busy schedule to share your expertise with us. Coming from a top-tier PV module manufacturer, coupled with her experience, I believe this webinar will enrich all of us, players from the academia, industry, with the latest updates in technology. And I trust these events will be benefited for all of us. And as you can see, it is an interdisciplinary and interdepartmental involvement. Ladies and gentlemen, I would like to thank all of you again for making the time to attend these events. I acknowledge and express gratitude to the organizer and host, SPECTRA, GERS, and the Faculty of Applied Sciences, UiTM, for organizing this event. Congratulations. With that, I officially launch the webinar entitled New Generation Photovoltaic Module. Thank you. Back to Dr. Farah.
Thank you, Prof. Malik. Ladies and gentlemen, it is now time for us to listen to the exciting topic about the new generation PV module. Again, I would like to remind that you can type all the questions in the chat box, either in your Google Meet or YouTube Live. Our committee will read out this question. Before we start, I would like to introduce our speaker of the day, Ms. Goh Yuk Mam. Born in Ipoh, Ms. Goh obtained her bachelor degree from University Technology Petronas, Malaysia, and completed her master degree from the University of Manchester, United Kingdom. Ms. Goh started as an engineer at TUV SUD and currently serves as the Regional Sales Manager, Module and System Solutions of Canadian Solar Southeast Asia. Her areas of expertise and topics of interest are mainly in the solar photovoltaic, electrical energy storage system, electrical vehicle, and electrical components, environmental and reliability testing, and certification. The floor is yours, Ms. Goh.
Hello, everyone. Can you hear me?
Hello. Yes.
Yeah, yes,
Okay, selamat petang and good afternoon, everyone. Yes, very happy and excited to be here on a Friday afternoon to share the new generations of the module technologies with you. And thank you, Prof. Sulaiman, for inviting me here as a speaker today, and the organizing committee, Dr. Azlain, Dr. Farah, and the Faculty of Applied Science from UiTM Shah. Thank you for organizing this, and the organizer of the event, SPECTRA and GRC. Thank you very much. Before I move into the details of the presentations today on this topic, please allow me to, I can share my screen right now, right? Yeah, okay. Please allow me to share a little bit of Canadian Solar. Can you see my screen right now? Okay, good. Yes.
Yes.
Okay, good. Yeah. Canadian Solar, founded in Ontario, Canada in 2001, listed on NASDAQ in 2006. We have now over 14,000 of employees globally and have presence in more than 20 countries. As you can see here, you have two divisions, module and system solutions, which I'm currently in this division. And we have another group is for energy group business that doing the project development. We are one of the world's largest solar module suppliers. We have made more than 16 gigawatt of module capacity in productions, and we have proven utility scale project development of track record over 5.6 gigawatt solar plants built and connected. We have global presence in over 20 countries, mainly in this four different regions. Asia Pacific, which I'm allocated in right now in the Southeast Asia region. We have the EMEA, European, Middle East, and Africa. We have the LATAM, Latin America, consists of Brazil and Argentina. And North America. Yes?
I'm sorry, can you please make your slide full screen because some of the participants can't see.
Yeah, sorry. All right, good. Sorry about that. Okay, I'll move on. And the last and the fourth region is the North America, Canada, USA, and Mexico. We have 17 production factories in 6 countries. We have the ingot and wafer factory and cell factory mainly in China, and the module factory in Canada, Brazil, of course in China as well, and Southeast Asia. We have 3 factories in Thailand, Indonesia, and Vietnam. We have achieved over 15 gigawatt module productions as of last year. If you can see here, 2020, we hit 16.1 gigawatt. And this year itself, we have a very aggressive target to hit of 25.7 gigawatt. And we have also reached 52 gigawatt cumulative of module shipments as of last year since 2002 to 2020. Yes. All right. We move on to the highlights of the topics for today of standardizations of high performance 210 cell module. And if you can see here, these are the cell and module technology roadmap. Previously, when we started, we have this standard fuel cell, which in the range of 100 plus to 200 plus watt peak module. And in 2017, we came out with the cool module. Cool stands for cooling, for your information, and dual cell is there for half cut cell, and which is in the range of 300 plus watt peak module. And in 2018, we have this bi-cool. Bi stand for bifacial, and this high cool stand for high power, and it reached about 400 plus watt peak modules. And in 2019, we have this bi-high cool, bifacial, means bifacial plus high power. And 2020 last year, we have this called high cool 5 and high cool 6, which can hit up to 545 watt peak power output. And this year, we are very excited to already launch in early of the year a mass production in next month, April. We are going to have this high-cool 7 and Bihigh-cool 7 for both for mono PERC, and which can hit up to 665 watt peak. And this is the high-cool and Bihigh-cool 7 series. We can see here there's a 7L and a 7N series. The 7L series is with the power output of 580 to 600 watt peak. And this 7N is with 640 to 665 watt peak. And the bifacial, as well, you can see the power output range. And this module can up to 665 watt peak with efficiency of up to 21.4%. And the power output degradation yearly for monofacial is 0.55% per year. And for bifacial is 0.45% per year. And we did the comparison with our previous 166 mm half-cut cell mono PERC 444 watt peak panel. This Series 7 can actually help to lower the LCOE of the project by 8.9% and the balance of system BOS by 5.7%. And as I mentioned just now, this is going to go live in mass production in April next month. Yes, we go into more details on the characteristics of this Series 7. In order to get a higher power output from the module, and at the same time to ensure that the hotspot of the hotspot performance of the module does not fall in the danger zone. Actually, it's a very challenging job. And this Series 7 is actually have this excellent hotspot performance. And let me explain in detail. Normally, modules, you have 3 diodes at the junction box. And the more cells that you connected to the diode is actually will result in increase of the dissipated heat per square cm. So if you can see here, this 7L series is a 60 cell, and this 7N is with 66 cell, is a half cut. Is only have 20 cell per diode, and the other one, 7N have 32 cell per diode, which significantly reduce the number of cells connected to one diode. And if comparing to our current product lines, which have the 166 mm cell, which have the 24 cells connected to one diode. And also compared to some other modules in the market that have 1/3 cut cells, not only half cut, 1/3 cut cells that which resulted in 30 cells that actually connected in series to one diode. And this actually increased the dissipated heat significantly. And we're talking about homogeneity. Yeah, there's 2 main reasons on why hotspot occur on the modules. First of all, of course, as mentioned in the previous slide, is the arrangement of the cells, arrangements of the design of the cells on the module, which resulted in the hotspot cells that becomes really, really hot. The other reason is during the manufacturing, you have the inhomogeneity of in the reverse current characteristics of the cells that go into the module productions. And CSI have this hotspot prevention technology. We call it the CSIR, Canadian Solar Infrared Technology, that it helped to prevent the hotspot risk originated from the localized leakage current at cell level. And how are we doing it? It's 2-steps method implemented, which called this CSIR, is to make sure that only cells that have at most homogeneity of the reverse current characteristics only go into the module productions. And at the same time, it discards the cells that did not reach the at most homogeneity. And next, we're talking about the lead and latte degradation, which has been a hot topic in the module industry in the past years. The lead stands for the light-induced degradation. The latte is the light and elevated temperature-induced degradation. And the lead normally occur in the early stage, quickly early stage after the installation, which affect the initial degradation. And the latte normally it can take up to few months or even few years for the power degradation to occur, and it's actually due to the continuous high temperature monthly or yearly. And CSI have this advanced CSAR, advanced regeneration technology that provides the industry lowest latte. And how are we doing it is we have this latte testing of each cell in each cell batch that we produce. And we're following this IEC standard, test the module temperature at 85 degrees C and at the energized mode, and at this different industrial standard of 96 hour and 500 hour. And if you can see here, this Series 7 is actually half of the maximum attenuation losses.
Ms. Go, I'm sorry.
Yes. No
Can
problem.
you press hide because some of your notes are not really visible to the participant. There's a hide. Aside from the stop sharing, there's a hide button. Could you please?
Okay.
Yes, thank you.
Is it okay now?
Yes, it's okay.
All good.
Thank you. Thank you. Yeah. All right, I proceed. Yeah, this is regarding the lead and the latte degradation prevention. And next, this Series 7 is using a very unique paving technology. We call it the HTR, heterotype ribbon, which actually you can see here using the cell space of less than 0.7 mm, which is also helped to overall reduce the dimension of the module. And talking about cell-to-cell connection, normally we have this two methods, and the first is the overlapping, which is not too advisable because it produces lower nominal output power. And the other one is this HDR, which is heterotype ribbon, and this is a very challenging. If you can see here, the connections from the ribbon from top of one cell to the bottom of the other cell with this limited cell space, and also at the same time you have to make sure that it did not damage the wafer at the edge of each cell during this connection. And talking about performance during low irradiance, and this Series 7 is proven that it has less losses, power output losses during low irradiance performance. And next is the compatibility of with the mainstream PV modules in PV inverters in the industry. We have tested and not only simulated during using online platform, but actually really physical connections in many sites globally, that it is compatible with most of the main brands, if you can see here, of the inverters in the market. And with the help of the higher power output per panel size, it can actually help to fill the strings of connections to even central inverter and the string inverter. And this Haiku 7 gives you more 20 kilowatt peak per 1500 VDC string, thanks to the low VOC of this Series 7. And it's also being tested compatible with mainstream PV trackers in the market. These are only a few few brands that is mentioned here. There's also other list of trackers brands that is also compatible with this Series 7. Then it can produce high power per string, and as I mentioned just now, thanks to the low VOC of each module, it can actually allow you to string more modules in one string compared to the lower output module. And this is, of course, a very important point also to highlight is on the financial modeling. When you do the costing, it can also help to reduce the cost at the tracker level for using this Series 7 in terms of your top tube, your purlins, your poles, the tracker that require to use the motor, and the number of pieces of modules will reduce significantly of the same power output system. and at the same time also your labor costs will be reduced. And talking about just now I mentioned the simulation. As I mentioned, we are not only doing the simulation online for this Series 7 with compatibility of the inverter or the trackers or different locations, but we also actually have this project reference being built globally, as you can see here in US and China and Australia mainly, to test out this Series 7. And it's always the case that difficult to know whether the project is bankable or not, because normally we'll doubt the performance and we don't trust the simulation result. And how to make sure that the simulation went well, and CSI has done our homework, like I mentioned, that we did the real installation on site, having the real testing parameters with different combinations of height, tilt angle, distance between rows, type of tracker, albedo, and how is all these factors combination, how to use it to optimize the maximum output of the system. And we have this well-controlled parameters set in our PVSys simulation that can help us to give a high certainty to the banks or the investors about how much yield that you're going to expect. And most importantly, we have used this to optimize the design of the system to become the lowest LCOE possible. And at the same time, of course, to preserve the high quality of the system so that it's able to operate and generate good yield for 25 years and more. And this, how this Series 7 is our goal to help you with that, and how to connect all these points together with real system being already constructed and connected, and the real data that we have, that we make this comparison. As you can see below here, this is a 27.3 megawatt peak utility projects happening in Los Angeles. And we did a comparison of the system using the 650 watt panels versus our previous model of 445 watt peak module. And this actually helped to significantly reduce the module cost, the structure cost, and construction costs, installation costs, and most importantly is the DC material site cost of the cables and balance of system of the combiner box. And to summarize, yes, this Series 7 give you higher power output per panel size and higher efficiency, and it has high reliability, as I mentioned, because it has gone through the CSIR, the infrared technology, advanced regenerations, and also to reduce the hotspot performance issue, and using the hetero ribbon and paving technology. And most importantly is help to lower the overall system levelized cost of electricity. And this module for the monofacial, it comes with 25 years performance warranty and 12 years product warranty. And the bifacial, it comes with 30 years performance warranty and 12 years product warranty. And the product warranty can be extended up to 15 years upon request. And next, we will discuss on the bifacial system design optimization. How to maximize the energy yield for bifacial system? Of course, the main components required is the bifacial modules and optimized mounting structure system and a suitable inverter. These are the 6 key factors for energy performance of a high bifacial system, which are included tilt, pitch, and height during the design, the ground albedo, the mounting system design, the system mismatch, cable management, and the inverter selection. And today I'll mainly touch on the cable management and the inverter selection due to the time constraint that we have. This exercise is done in China So, and I today only will share on the fixed system. We do have the data on the tracker system as well, but due to time constraint, I will share mainly on fixed system today. And bifacial gain gradually increases as array pitch becomes wider, as you can see here. But of course, at the same time, we have to take note on the LCOE as the more reasonable index to use for optimization of bifacial system. As for the array height, as your array height continues to increase, your bifacial gains differences decreases gradually. If you see on this graph here, that the bifacial gain differences decrease when your array height increases. So it's good to, we normally start with 1 meter as a starting point, and you can move add on for further optimization. And talking about the array width, when your array width is decreased, will lead to a lower irradiance non-uniformity and will affect a higher bifacial gain. So it depends on how you want to arrange your module layout as a portrait or landscape that will give you a reduce in your array width that actually help you to have a higher bifacial gain. Next is the ground albedo. A lot of people mix the albedo with the bifacial gain. Yes, and actually ground albedo is one of the key factors in bifacial gain contribution. And how to measure albedo is the bottom irradiance divided by the top irradiance from the parameter that you install on site. So if you can see from this table, it's extracted from the PVC's help menu. You have different kind of environment, the snow, the grass, the concrete, galvanized steel that give you a reference point of the albedo factor that you can use for your simulation. And talking about shading factor, bifacial gain sensitivity increase with ground albedo, of course, and we always could try to reduce the shading effect from the mounting system, and the balanced bifacial gain and the mounting system will increase. If you can see from the graph, when the shading effect is getting higher, of course, your bifacial gain will get lower. Same goes for the mismatch factor. If you have a higher mismatch factor, your bifacial gain will also reduce. Let's talk about the cable management that just now I say I will highlight on the cable management and the inverter settings. If you look at the layout, first type, portrait-oriented, 1 row, have to make sure that the return cable or the cable jumper needs to be fixed onto the torque tube to avoid any shading on the back side of the module, because we are using bifacial modules in this system. Next layout, second option, portrait-oriented, but with 2 rows this time. You can see normally for last time system, we like to use this traditional U-shaped connection, is to reduce your cable line, of course, but we'll recommend this I-shaped connection instead, in a way to separate the modules into 2 rows, strings, and you can see on the right side, to reduce the influence of irradiance non-uniformity. Yeah, so example, like if you have a higher shading effect on the top row, or your bifaciality gain is higher on the top row, it won't affect the other row. Layout options 3, we have this landscape oriented. Just now was portrait oriented. This now is landscape oriented, 2 rows. If you can see the connection on this left side is the connections of the cable. And if you have 4 rows that when you connect in landscape, it is advisable that you connect row 1 and row 2 together, and row 3 and row 4 together. And this will help to reduce the power mismatch. And we need to use a special cable clamps are more recommended for bifacial module in terms of cable management, so that it won't disturb the bifaciality at the real side of the module. And these are the 3 types of cable clamps that normally used in the market for bifacial modules connection. Next, talking about the inverters. highlight of the inverters factor is the 6 factors. You have to make sure the inverter is installed at the location that does not obstruct the modular side irradiance. Higher input currents are better suited for bifacial. And DC-AC ratio at STC for bifacial system typically will range from 1:1 to 1.3. And if it's integrated with DC combiner box, you have to put into the fuse design values considerations. And some key principles, bifacial design is an iterative process and should be done with industry standard simulation tools such as PVSys. And the third additional bifacial factor for 1.3 means, if you can see from the data sheet, normally it's 5, 10, 20, 30%, is used to estimating the maximum bifacial gains from STC values. Sorry. Clipping loss, this one more related to 4-season country, where they have this higher output during the spring and the summer season, and yeah, and not so much related to our region. And as mentioned, how to minimize the shading effect. This is the worst practice that we see on site. The combiner box and the inverters are installed directly on the real side of the mounting structure, and this will actually disturb the bifaciality of this module. And a good practice, of course, is to put the combiner and the inverter on the mounting structure side, and we keep the distance of more than 1 meter, if you can see from the picture. Last thing to talk about is this string sizer. That is, if you can Google it, Canadian Solar String Sizer. It's a very like a quick online platform on how to string inverter. You can also help to generate this inverter sizing report. When you have discussion with your investor or your clients, it gives you a very quick how many inverters that you have that you need to connect, and the DC-AC ratio result. Later on, I will share on the layout more. And this is mentioned on the PVSys help menu earlier. And we did a quick simulations on using this 125 CSI inverters and with the bifacial of the poly and the mono. Later, I'll show the comparisons in the table. And this is how it looks like, the platform. From starting, you can input the albedo of the ground and also the low and high temperature, and you can select the drop down of the module type, which bifacial module type that you are using. Then all these values will automatically tabulated out, and you can select also which type of inverters that you need. These values also will automatically tabulate out, and will give you the result here. As you can see, the DC-AC ratio, which will let you know whether it falls under the acceptance value of the inverter. If it does not, this shown orange means it's still under the acceptance value, but it's actually already pushing the limit because it's in orange color. If it's in red color, it's actually will inform you that it's actually out of the acceptance value of the inverter. And also will tell you the total DC power output of the system and the number of total panels that require for this system. And it's just a comparison between 3 different scenarios that you can do quickly. This is poly, and this third one is mono. It can tell you, as I mentioned just now, how many number of panels that you require, how many strings, and DC-AC ratio, and this estimated financial gain that you can see from the data sheet. If it's 30%, from the data sheet, what are the VOC, ISC from the data sheet? If it's 9%, yeah, that you can see the different parameters. The summary of this is, if your albedo of 1, in reality, it's not possible, of course. It actually corresponds to best case scenario of 30% gain from bifaciality. And when albedo reduce, your bifacial gain will also reduce, and your DC-AC ratio actually increase. And this string sizer platform takes only account of 2 different key factors. As you can see just now, you will need to input only the albedo and the minimum and maximum temperature. So this, as mentioned, this platform is just used as the estimation that you need to quickly know how many inverters that you need and how to string the inverters, and actual values actually can be differed. So it is still recommended to simulate the values based on industry standard solution such as PVCs if you want to go in more detail. As I mentioned just now, if you do have the combiner box is integrated, you do need to follow the values consideration. For the fuse minimum value, we follow this formula that is also given in the CSI Bifacial module installation manual. And the maximum of the fuse, you can follow the lower of the two fuse maximum from the PV module datasheet or the inverter datasheet. And understanding of PV module datasheet, this is the last part of just to highlight here. Normally you will see in the module datasheet, we have this STC values of this power output of the module. We have if bifacial gain is 5% or 10% and 20% and 30%. And many people always questions me that why is only 30% and don't have 40, 50, 60? And this is actually related to the UL 1703 and IEC 61703 standard limitations. That's all for today's sharings. Mainly touch on the new module technologies based on 210 mm cell, and also how to optimize your design using bifacial modules. And the last part is the understanding of the PV module datasheet. Thank you very much. Have a nice day, everyone, and have a nice weekend ahead. Anything, you can contact me for further clarifications or you need more information. Thank you very much, everyone.
Thank you very much, Ms. Go, for your sharing. Without further ado, I would like to invite Prof. Sulaiman as the moderator for the Q&A session. Over to you, Prof.
Okay, thank you, Dr. Farah, for the introduction. Thank you, Ms. Go, for a wonderful presentation. It's a lot of information. I was squinting my eyes and see the numbers. Looks like I have to attend a separate class for you. Okay, let's go. Yeah, a lot of information. Ladies and gentlemen, before I proceed for this session, I'd like to explain a few things. The theme of this session will be basically, it is a question and answer session, but we have an open discussion as well. So the theme of the session I would like to highlight would be three things. A, we will focus on the direction of the PV technology. And item B would be the data sheet of the bifacial PV modules. And item 3 would be the practical systems in the field. So these are the three focus areas that we can look at in the limited time available. And before we start, I'd like to also explain how this is going to be done. Our technical team is led by Dr. Khairul Nadim, and he has been compiling the questions, as you can see in the chat box. And what will happen is Dr. Nadim will be reading the questions, but I will moderate, meaning he will read the questions and I will ask if that question should be, or rather I will point that question to Ms. Go. And if a question is not relevant to the three areas, I will skip that question. So I reserve that privilege because I'm the moderator. Okay, so let's focus because we have a limited time. So I would like to invite Dr. Nadim. Can you please read the first question?
All right. Thank you, Prof. So we've got a few questions here from Mr. Zamir Fakulti. His question is if the lower LCOE of 8.9% is assumed, how much of performance gain from the bifacial panel?
That's a valid question. Dr. Nadim, repeat that, please. That's a valid question. Ms. Go? you can entertain that. Dr. Nadim, again, please.
I repeat again. So the question is, if the lower LCOE of 8.9% is assumed, how much of performance gain from the bifacial panel will we can get?
Okay. Can I answer now?
Yes.
Okay. Yeah. So as I did put in the slide just now, the 8.9% is comparison for two different monofacial modules. It does not it's not comparing with mono and bifacial. So it's actually comparing monofacial of 650 watt panels with monofacial of 445 watt peak panels, as mentioned on the slide just now. So if we would need to compare with bifacial, we actually need to compare bifacial of the 650 and bifacial of 450 example. Then the percentage, it might differ. Yeah, we have to compare apple to apple. Yeah. Hope that answer your question.
I hope the answer from Ms. Go is can satisfy the.
Okay. Next question, please. I see a lot of questions here. Next question, Dr. Nadim.
Okay, so next question is from Dr. Heslin. For Haiku 7, what is the temperature coefficient for power? And is there any significant difference among them?
Okay, that's a fair one. Yeah.
Yes. So it is written on talking about the temperature coefficient, right? Yeah, let me pull out the data sheet as I cannot remember it. The temperature coefficient for the power is negative 0.34% per degree C. Yeah. So it's still quite similar to the smaller cell module, I would say.
Okay.
Yeah. Next question, please.
Okay. And then another question from Dr. Heslin. Bifacial is like having two PV array orientation, isn't it? Okay. Question mark. Okay. How is the management of the cell output power within PV? Sorry. Within a PV module, what different input of solar ingredients in each side of phase of the solar module?
Question not clear.
Okay. The question is bifacial is like having a two PV array orientation, isn't it? That's the question. And then how is the management of the cell output power within a PV module with different input of solar ingredients in each side or phase of these two bifacial PV array orientation?
Ms. Go, understand the question?
Not really. Can help to.
Okay, I think this is like
first question.
They've got two sides, yeah? Two sides. One is facing top, one facing bottom. So it looks like you have two modules.
Yep.
So how do you calculate how do you measure the output total for two phases?
Yes, that's why I put in the six key factors just now. Of course, if you look for the front side, it's quite normal. I mean, general. It depends on your tilt angle. That is the most we talked about previously. The bifaciality gain of it, of course, it depends on the six key factors just now I mentioned. The first, if you remember, the tilt pitch and the height, and of course, next is very important factor is the albedo. What of type of ground that you are construct your modules on top. I mean, what ground is at the bottom, and of course the power mismatch and the system mismatch losses. And next, of course, is the cable management, and the last is the inverter, of course. How you string your inverters.
Dr. Nadim, let's focus on questions outside of UiTM first.
Yeah, I've got another question. Dr. Sharil, can I take his question? Dr. Sharil.
Outside UiTM, is it?
Dr. Sharil is our clique. Dr. Sharil Irwan Sulaiman.
Oh, you mean the head of girls?
Okay, so I just read out his question. Okay, are the voltage of front and rear are relatively equal, and total current from PV module, is it equal to the current from front plus with the current from rear? That's the question from Dr. Sharil.
Please go.
Regarding
So if I understand correctly, the question is whether the front of the voltage and the current produced from the front is the same as the rear, right? Yeah. So we don't actually separate the front and the back. We take the whole module as it is. So if you see the data sheet, normally it will put the STC value first line, and the next line is 5%, 10%. So if the 5% is already the value given is actually for as a module as a whole. It's not like your front you get the STC and your back you get additional 5%. No, it's not that way.
Okay.
Dr. Nadim, questions from outside of UiTM, please.
Okay. So I got another question. The same from Zami Fakulti. He's got the question. He's got another question. So I have seen development of bifacial modules in vertical orientation. Is this a better orientation than the typical mounting angle, two faces angle? Is it?
Okay. If I understand correctly, the question also. Okay. Is it comparison fixed system with single axis or dual axis? Is it?
Oh, yeah, mounting
vertical.
Oh, vertical.
Vertical orientation. Yeah, like northern latitude.
Yeah, I don't think it's very feasible in our region in Southeast Asia, actually. Yeah, because of we are very near to the Catholic steamer line, so yeah, it's not so relevant, I think, to be deployed in this region.
Okay. Okay, Dr. Nadim, next question.
Okay, now another question, also from outside, I think, from Mr. Rizwan Muhammad Jaiz. He's got two questions. So the first one, is it possible to install bifacial for floating solar? And then the second question is, if yes, how to generally estimate the performance gain of bifacial for floating solar?
That's a good one.
Yes, good one. Yeah, I see the question here as well. Yes, of course it's possible to install bifacial for floating solar. It's mainly due to previously we were prefer to use glass-to-glass module for floating because of the corrosion effect from the backsheet. But of course, we have most of the manufacturers actually have stopped productions of the glass-to-glass module. But actually, we will propose on this bifacial instead. Yeah, because of the pricing of the bifacial, the gap from the monofacial actually is getting smaller. So it is one of the way of using glass to glass as well. But at the same time, you get the bifaciality of the real side. So yes, it's possible. Second, if yes, how to generally estimate the performance gain? Okay, but performance gain, again, bifaciality gain, as I mentioned, very much depending on your design. This is back to the 6 key factors that I presented just now as well. Yeah, so yeah, we need to go through the 6 key factors and to see how to optimize the system for your floating solar.
Okay, all right. Next question, Dr.
Okay. So this is another this question from Encik Zami Fakulti. Is there any correlation between diffuse radiation instead of direct radiation to bifacial gain? Any correlation between diffuse radiation to bifacial gain?
Yes, I understand. Yeah, so there is a correlation, but the effect percentage is too small. It's too small that it need to be taken into account.
Right.
Yeah.
Okay. Okay, and then another question from Mr. Umar Sulaiman. This is rather an application question for the higher power class of PV modules. Let's for example like 540 watt power. can I just ask with what type of inverter was it intended to match with the string or central? And then the reason of us asking this question because for string inverter application, most string MPPT can take up to one string only for the new ISC of PV modules, as a new PV technology is focusing on lowering the VOC, but not much on ISC.
Yes, understand your question fully. Yeah. So if we want to compare string and centralized inverter, of course, previously for large scale projects, for project development, they would prefer to use centralized inverter because back to the cost of it. But as times go by now, even string inverters is actually at a very cost competitive as well. And in terms of reliability, it's also quite easy of one-to-one exchange, and during the downtime as well of one particular string that you doesn't need to actually shut down the whole centralized inverters. And we're talking about, yes, you're right, these larger modules have higher ISC INP, which come up to about 17 M compared to the previous 166 mm cell module, which only had about 11, 12 ampere. And yes, this will limit the inverter string to only one string per MPPT. But if you look at the good side of it is if you only connect one string per MPPT, it can actually help you to improve on your string monitoring as well per MPPT. And secondly, it's still the same if you able to reduce the number of modules due to the higher power output per panel size. It's actually, even if you connect one string per MPPT, it can actually help you also to reduce the number of converters that you need to connect. So yeah, hopefully it answer your question.
Yeah. Dr. Nadim, my question from Maslina Osman, from Dr. Maslina Osman.
Okay.
Nadim.
The question is, who is your typical target market for bifacial?
Okay. Typical target for bifacial modules, right?
Yep.
Yes.
Of course, we have deployed a lot of bifacial modules in the China, Australia, and US market specifically. US, taken up a very high percentage of it. But we do see it coming in this last year, started especially in the Southeast Asia, especially from Vietnam. Some of the project developer that already start to put in the design with bifacial modules. It's of course mainly that I mentioned just now is still back to the cost versus the bifacial gain that they can get, as the gap of the monofacial and the bifacial modules is getting smaller. So that's one of the attractive part as well, that we see it coming up and coming in the Southeast Asian region.
Dr. Nadim, question from Miss Adila Rosdan.
Miss Adila, okay. Miss Adila asks, what's the performance warranty for the first year and subsequent years for the bifacial modules?
Yes, so for first year will be 2% power degradation, and subsequent year, as mentioned just now, is 0.45% for bifacial modules.
Okay. Hope that answered the question by Miss Adila. Okay, now,
question from Mr. Philip Yap. Nadim, from Mr. Philip Yap.
Okay. What is the fill factor in this new 665 watt PV Canada Solar? Is it?
Yes, I know. It's not written in the data sheet, of course, for fill factor in most of the manufacturers. Please write to me. I can inform you. Because that one more related to the BOM list, and please write to me. I'll type my email address here. Then
I'll
inform you accordingly.
Miss Go.
Okay, thank you. Dr. Nadim will take one more question. Just one more. Time is up. Actually, just one more question. Last one.
Okay. Okay, this question came from Dr. Sharil. He's got two questions basically. So are the cell from the front and back of the module connected in series? And then the second is, are the PV mounting structure for bifacial module installation usually supplied by the PV module manufacturer as well?
Sorry, I didn't get the first question.
Okay, the first question is, the cell from front and back of the module connected in series or not?
The top module and the bottom module are they in series? Are they not in series?
Yes. I mean, we talked back regarding the cell connection. Yes, yes. It depends on if it's 60 cells, then it's 20 cells connected in series. Yes.
And then the structure, the mounting structure, is it supplied?
No, we don't supply the PV structure, but of course, if you need some recommendation that we already done the on-site installation together with our modules one, yeah, we can recommend, of course. Yeah.
Okay, Dr. Nadim, thank you. There's the one last one. Ms. Go, I said last one, so I have to entertain this. The last one, how many panels required for an average household? And what's the ROI inclusive of maintenance? The general question.
Okay, yeah. So average household, let's say a double story residential, we can talk about 4 to 5 kilowatt system. It's about eight pieces of panels, I would say, and the ROI inclusive of maintenance will be 3 to 4 years, I would say, for now, with the very good policy that we have in place for residential market. Yes.
Okay.
Thank you.
Thank you, everybody. Thank you for all your questions. Thank you, Dr. Nadim, for reading out, and thank you, Ms. Go, for entertaining them. What I will need to do now is I will need to do some wrapping up. Basically, Ms. Go has presented a brief snapshot of what can be expected, what's coming, and some application issues that need to be looked into. She's mentioned 6 items that we need to look further into. So again, I would like to thank you all for your questions. I'd like to thank you, Ms. Go, and I'd like to thank you, Dr. Nadim, for reading the questions. Okay, what I'm going to do now is basically I'm going to wrap up and close this session. This is what's expected of me to do. From the presentations and the questions and the discussions, I can, if I may use this word, cluster. It sounds dangerous, yeah? But if I can cluster these things, these issues discussed, I can see 4 clusters. Not solar cluster, definitely, but economic issues. There were questions about LCOE, there were questions about ROI, and there were questions about how much it costs. So some economic things, and there were some questions that I can cluster into the technical matters, like the temperature coefficients and how it's different and how it's connected in series or in parallel. So those are the things that I cluster into the technical matters. Design and connection issues. There's another cluster that I think I can cluster them into the matching between the new modules, the bifacial modules, with inverters. So that's another issue that we need to look into because of the number of strings, number of MPPTs available, and the capacities. There are now 600 plus watt modules as you compare them to the early years when I guess Ms. Go was in standard 1 maybe. That time the module, what, 50 watts or something, 25 watts perhaps. So now we are talking about tenfold. So some matching issues. And the other cluster is obviously the application type. There was a nice map that Ms. Go showed and talks about the upgrade or the significant increase or the rather insignificant increases as well in the various regions of the world. And it'll be interesting to find out what kind of parameters, what kind of results we can see if we do them, install them in the Southeast Asia region. Some of our participants are from Southeast Asia. They are not all from Malaysia, as you can see some names there. They're coming from other parts or other countries in Southeast Asia as well. So I think we need to understand more of these things, on the economic things, on the technical matter things, and the matching design of the components, as well as the application issues. As Ms. Go mentioned, we have there was a question on the putting up on a vertical thing, and since we are vertical modules and we are on the horizontal, we are near the Khatulistiwa, so it's on the horizontal. So we have dust issues. We don't have snow yet, so we have albedo issues. So things like that need to be looked into later on, further on. So those are the 4 clusters that I can see that we have come up based on the discussions earlier. And we need to move on. We need to move on as a way forward. In the context of this webinar, I can summarize that it is clear that we need all stakeholders to get involved, especially the industry players like Ms. Go and her colleagues and her competitors as well. We need input from research and educational organizations. We've got a lot of academia people here. We got postgraduate students here as well, and we got a pool of talent from the Southeast Asia region. And this is kind of new for us. And let's not make a riot out of this, but let's be scientific and systematic. Meaning, in our context, perhaps we can make one small move in terms of working together with SPECTRA, with GUS, and with the other organizations within Southeast Asia. And let's see what happens when we place the Canadian solar bifacial PV modules in this region, and see what happens, because it's an equatorial region. It's not fully tested, and there's not enough information on that. There's not enough data that we would like to know more. So perhaps we can do this thing together. A small step for us, but a big step for mankind in that sense in Southeast Asia. That's where we're heading. So I implore and I invite all of us here with the industry. Let's work together and let's move on from here. So those are my conclusions from the discussion that we have, and based on the presentation and questions. Ladies and gentlemen, the organizer has also requested that I do the closing. Perhaps I don't want to overexpose myself, so I think I'll make a very short closing session. So thank you again, everybody, for attending this session. And as a closing remark, on behalf of the organizers and hosts, SPECTRA and GUS, and their respective faculties, I express deep gratitude to Ms. Go Yokman, for graciously accepting our invitation and entertaining all questions. I must be honest to her that it was a short notice, but I'm very happy that she decided to entertain us anyway at a short notice. And it definitely has given me insights into the topic. I also express deep gratitude to all committee members, and especially to all attendees, all of you who attended this, and to find out what's going on in terms of PV development. And I thank all of you sincerely with my heart. And I hope, on behalf of the organizing committee, that you have gained some knowledge and found what you were looking for. And most importantly, I hope we have delivered what we thought we would like to portray. I hope we have entertained all your questions and filled up the answers that fill up the questions of the answers to your questions. And we look forward to more engagements from all parties in the near future. And thank you again. With that, I hand over the mic to Dr. Farah, the MC. Thank you, Ms.
Thank
Go.
you. Thank you both, Prof. Sulaiman and Ms. Go. It's very worth sharing session. Okay, before we finish off our session, can I ask everyone to open their videos so that we can take a picture together for kenang-kenangan? So could you please turn on your videos so that we can take pictures? Okay, and be ready. Okay. Then hold on for a second. Okay, you ready, guys? Okay, 1, 2. Hold on for a second. 1, 2, 3. Okay. One more time. 1. Freestyle. 1, 2, 3. All right. Thank you so much, guys. Before we end, I would like to remind you, please do not forget to fill in the attendance and also the survey form as per attached in the chat box, because for your UiTM staff, we provide you the training hours. And on behalf of SPECTRA, we would like to thank you for all your attention and also your time. See you next time. Thank you, guys.